Hello dear students, this is grade 11 mathematics lesson on unit 9, further on trigonometric functions. This chapter is designed for natural science students. So today we will see inverse of trigonometric functions. After revising this lesson, you are expected to identify intervals where trigonometric functions has an inverse and sketch the graph of inverse trigonometric functions and compute the values of some inverse trigonometric expressions. So let's continue to the lesson. A function f is said to be invertible if it is 1 to 1. A function to have an inverse, it must be 1 to 1. So since all trigonometric functions are periodic, if you see sine, its graph is this form. It's a periodic. If you use horizontal line test, it's not 1 to 1. So it doesn't have an inverse. But if you restrict the domain of each trigonometric function, it will be 1 to 1. So we need to restrict the domain of each trigonometric function so that it is 1 to 1 over the given domain and it becomes invertible. Now let's start from inverse of sine function. If you restrict the graph of sine function from negative pi over 2 up to pi over 2, it will be 1 to 1. And its inverse means, I hope you know how to determine inverse. If AB is element of certain relation or a function f or r, the inverse will be, it is BA. The inverse will be BA. It's our inverse. Therefore, here the x coordinate will be changed into y coordinate and the y will be on x. So you can see the inverse here. Negative 1, 1, negative 1, 1 on x-axis and these values on y-axis. When the value of y is 1, the value of x is pi over 2. So interchanging this, when the value of x is 1, the value of y is this pi over 2 is inverse. And here again, when the value of x is negative pi over 2, the value of y is negative 1. So this will be this negative 1 in pi over 2. Drawing the graph, the inverse of sine function graph is this one. And the inverse of a sine is written in this form. Y is equal to sine x. Its inverse is denoted by y is equal to sine inverse of x. So here, inverse sine or arc sine function. Inverse of sine can also be stated like arc sine function. So the inverse of sine or arc sine function is denoted by this symbol, sine inverse or arc sine. And it is defined by, it is sine inverse of x is equals to y or arc sine of x equal to y. So if this happens, sine inverse of x is equal to y, this implies always sine y gives you x, sine y gives you x. And in addition to this, the domain of sine inverse of x, as you can see here, it is between negative 1 and 1, the domain. And its range is from negative pi over 2 up to pi over 2. So its range is this negative pi over 2 between negative pi over 2 and pi over 2. Now let's continue. Look this up. As we said earlier, inverse sine function, its domain is this between negative 1 and 1. Its range is it is between negative pi over 2 and pi over 2. And from the definition, you have the following. Sine inverse of x is equals to x if remember in unit 1 of your lesson about relation function, you have this one, f of f inverse of x, the composition of inverse function in the function always gives you x. Not only this one, f inverse of f of x will also gives you x. So here is a composition of sine and its inverse, so it gives you x. In this case, sine inverse of x is defined on -1 up to 1. In this case, sine inverse of sine x is x, but in this case, x is an angle here. So for inverse function, the angle is between -power2 and power2. So the value of x must be between this interval. Now let's proceed to example. Here, calculate sine inverse of -1/2, sine inverse of 1, and sine inverse of sine pi over 4, and sine inverse of 12/13. Solution for A, sine inverse of -1/2 means is equal to assume it is theta, and then sine theta means it is -1/2, and this theta is between -pi/2 and pi/2. Sine inverse function is defined on this. So -1/2, and it's found on -pi/2 and pi/2, this part only, this part. On this interval, we need to find theta. Sine is, I hope you know, sine is 1/2 at an angle 30 degree, but this one is negative, so the angle must be on fourth quadrant. So the fourth quadrant corresponding to angle 30 is -30. Therefore, you have this one. You have -30 degree. Therefore, theta in this case is -30 degree. Okay, B, sine inverse of 1. Sine inverse of 1. Sine inverse of 1. Assume it is to be theta. So sine theta means it is 1. So sine theta is 1 on this interval is at 90 degree. Therefore, theta is this 90 degree here. Theta is this 90 degree, or it is pi/2 in terms of radian. And here, sine inverse of sine pi/4 is a composing function. It gives itself, so the answer will be this pi/4 for this case. So the answer for this one is pi/4. And here, sine inverse of 12/13 is also a composition of a function with its inverse. So it gives you this one, 12/13. 12/13. Okay, now let's continue to the next example. Okay, here it says compute tan sine inverse of 3/4. Okay, to solve this, solution, let's assume this to be theta, sine inverse of 3/4. So sine inverse of 3/4 is equal to theta. So sine theta gives you, sine of theta gives you this 3/4. Now, using reference triangle, this reference triangle, assume this is theta. Sine theta means it is opposite over hypotenuse. The opposite side here is this 3, the hypotenuse is 4. Using Pythagoras theorem, you can determine this one. So it is 16, 4 squared minus 3 squared, 16 minus 9. it is 7. This you will have this one, square root of 7. So now here we are asked to find this one, tan of sine inverse of 3 over 4. So this equal to this tan of, we assume this to be theta, sine inverse of 3 over 4 to be theta. So we need to find tan theta. We can use this reference triangle to evaluate tan theta. Tan theta is opposite over adjacent. So simply it is 3 over root 7. So the answer will be it is 3 over the square root of 7, or rationalizing this you get 3 root 7 over 7. So this will be the answer. Another example, here let y is given to be 3 plus 2 sine inverse of 5x minus 1. Then you are asked to solve for x in terms of y, and you are also asked to determine the range of values of x and y. So let's see the solution together. We have this one, y is equal to 3 plus 2 sine inverse of 5x minus 1. We need to solve for x. So to solve this, first take this 3 to this side. You have y minus 3 is equal to 2 sine inverse of 5x minus 1. And then divide by 2. You will have this one. When you divide by 2, sine inverse of 5x minus 1 gives you y minus 3 over 2. And then sine inverse of this means sine of y minus 3 over 2 gives you 5x minus 1. If you remember, sine inverse of x is equal to y means sine y gives you x. Sine inverse of this number means sine this number gives you 5x minus 1. So you will have this 5x minus 1 is equal to sine of y minus 3 over 2. Taking 1 to the other side, you will have this one, and dividing by 5, x is equal to 1 over 5 plus sine y minus 3 over 2 over 5. You have this one. So this is the value of x when it is expressed in terms of y. And here we are also asked to determine the range of values of x and y. Okay, here this one, 5x sine inverse of 5x minus 1 will be defined when this value is between -1 and 1. Therefore, 5x minus 1 must be on the interval between these two, -1 and 1. So, adding 1 on both sides and dividing by 5, you will have this one. -1 plus 1, it is 0 over 5, 0, less than or equal to x. It is -1 shifting to this side. You have 1 plus 1, it is 2 over 5. So the value of x ranges between 0 and 2 over 5. And the value of y. The value of y, here you can see this one, sine of this. So this value ranges, is an angle, it ranges between -pi over 2 and pi over 2. Therefore, y minus 0 over 2 is between -pi over 2 and pi over 2. So multiplying this by 2 you have, and adding 3 both sides, -pi plus 3 less or equal to y, and adding 3 on the other side will be pi plus 3. So you will have this one. Now let's continue. Inverse of cosine function. The inverse of cosine function is defined on the interval 0 to pi. On the other part, if you take, it will not be 1 to 1. So the 1 to 1 part is from 0 to pi, and the inverse graphically this one. So cos inverse is defined in this form. The inverse of cosine, or we call this arc cosine function, is denoted by this symbol, cos inverse or arc cos. and it's defined by this one, cos inverse of x is equal to y, if and only if the value of y ranges between 0 and pi. The range is between 0 and pi, and the domain is between -1 and 1. The domain of cos inverse of x is between -1 and 1. The range is between 0 and pi. The range is between 0 and pi. And from the definition, you will have this one. Cos inverse of x is x, and cos inverse of cos x is also x on this interval. So let's see example here. Here we are asked to calculate cos inverse of root 3 over 2. In same procedure as we did for sine inverse, we'll continue like that for cos inverse also. So solution for this, cos inverse of root 3 over 2, this equal to theta, assumed to be theta. So cos theta will be equal to the square root of 3 over 2. And this is defined where theta is between 0 and pi, which means on this interval. If this one is negative, the angle found is in second quadrant. If the angle is positive, the angle is found in the first quadrant. Therefore, cos theta is root 3 over 2 at 30 degrees. Therefore, it's a first quadrant angle, it's 30 degree, gives you cos theta to be root 3 over 2. Therefore, the value of the theta here it is 30 degree, or it is pi over 6. I will leave this for you to try. Now let's continue the other part. Okay, another example. Compute sine cos inverse of 1 over 4. Okay, let's see this together. Let's assume the inner part to be cos inverse of 1 over 4 to be theta. So it is cos inverse of 1 over 4 is equal to theta. This implies cos theta gives you 1 over 4. And draw a reference triangle for this. Reference triangle for this, you will have this one. You have theta here. Cos theta is this adjacent over hypotenuse. So the adjacent is 1, the hypotenuse is 4. Using Pythagoras theorem, you can find this one. It is the square root of 4 squared minus 1. It is square root of 15. So from this, cos inverse of 1 over 4 means sine, we assume to be this theta, sine theta. Therefore, sine theta is equals to opposite over hypotenuse. So it is root 15 divided by 4. This will be the final answer. Okay, let's see inverse of tangent function. Inverse of tangent function is defined on the interval negative pi over 2 to pi over 2, and the graph is displayed like this. So let's define it. The inverse of tangent function is a function, it's denoted by tan inverse of x or arc tan x, that assigned to each real number x the unique real number y in this interval says that x is equals to tan y. Tan inverse of x is equal to y means tan y is equal to x. And as you can see, the domain of this tan inverse will be this, the set of real number. Its ranges between negative pi over 2 and pi over 2 without including pi over 2 and negative pi over 2. So the domain of tan inverse is this real number, and the range is it's found between negative pi over 2 and pi over 2 without including negative pi over 2 and pi over 2. And from the definition, we will have this one, tan inverse of x, it gives you x, or real number x. And tan inverse of tan x is equal to x. In this case, x is the angle, so the angle ranges between these two, negative pi over 2 and pi over 2. So please try to compute this by yourself as we did for sine inverse and cos inverse. So I'll leave these examples for you. Okay, now let's see this one. Express tan cos inverse of x in terms of x. Solution. Let's assume cos inverse of x to be theta. This implies cosine of theta gives you x. and then draw reference triangle. So the reference triangle will be, we have theta here, cos theta is x means cos theta adjacent over hypotenuse. The denominator is 1, the adjacent is x, the hypotenuse is 1. Using Pythagoras theorem, you can find this. It is the square root of 1 minus x squared. And then we are asked to find tan cos inverse of x. So tan cos inverse of x is equal to tan theta, since we assumed cos inverse of x to be theta. So tan theta is equal to its opposite side divided by the adjacent, the square root of 1 minus x squared over x, but this is defined for x between -1 and 1 without including 0. Okay, now let's see inverse of other trigonometric function, cotangent, secant, and cosecant. So let's see a definition. The inverse of cotangent function is this, written cot inverse, or this arc cot, and it's defined by y is equal to cot inverse of x, and this will happen if and only if cot y is equal to x, and the range for this cot inverse is for y is found between 0 and pi, and its domain is real number. The inverse of secant function is given by sec inverse of x, or arc sec x. Is defined by this form, y is equal to sec inverse of x, and this happens if and only if sec y gives you x, sec y gives you x, and the domain of this sec is this absolute value of x greater than or equal to 1. That means x is greater than or equal to 1, and x is less than or equal to -1. This means, and its range is found between 0 and pi inclusive, and without including pi over 2, and the inverse of cosecant function is simply written in this form, cosec inverse of x, or arc cosec x, and it's defined by this one, y is equal to cosec inverse x. This happens if and only if cosec y gives you x, and its range is on this interval from -pi over 2 to pi over 2, including pi over 2 and pi over 2, and without including 0, and it is domain is absolute value of x greater than or equal to 1. So this is a definition of inverse trigonometric functions. Now let's see example for this. We have this one, cot inverse of 1 over root 3, sec inverse of root 2, and cosec inverse of -2 over root 3. Let's do one of these questions. Here, let's do a cot inverse of 1 over root 3. To find this, assume to be x. So from this, cot x gives you 1 over root 3 for this interval. So cot x is 1 over root 3 means tan x is root 3. You take reciprocal. Cot x, make it tan x. And you can take the reciprocal of this one. So from this you get that tan x is equal to root 3. So this gives you x to be this 60 degree. So please try the rest one. Okay, to summarize what we have seen today, 1, sine inverse of x is defined, its domain is between -1 and 1, its range is this, defined on -pi over 2 up to pi over 2, and cos inverse of x is domain is this defined on x between -1 and 1, and y is between 0 and pi. Tan inverse of x is defined on x from -infinity to infinity, and y between -pi over 2 to pi over 2. Y cot inverse of x is defined on -infinity up to infinity, and y is between 0 and pi. Y is equal to sec inverse of x is defined on for x absolute value of x greater than or equal to 1, and y is between 0 and pi without including pi over 2. y is equal to cosec inverse of x is defined on absolute value of x greater than or equal to 1 and y is between negative pi over 2 to pi over 2 including without including 0. So these are the basic concepts that we have seen today. So for you, I'll give exercise. Do exercise 9.2 on page 360 and read examples on page 335 to 359. This is all about today's lesson. So I'll see you on next class. Until then, goodbye.